Hey, TechKnowStuds! When Flash first came out, one of the memory cells inside of Flash stored 1 bit of information. One thing we've been able to do is store multiple bits in each one of those cells now. But how do we do that? In this lesson, let's explore how we got to store more than 1 bit of information per memory cell. One of the severe limitations of Flash when it first came out is it just didn't store a lot of data. That every single transistor that was in on it could store 1 bit of information. And so what we did is we figured out how we could store multiple bits of information using the same memory cell. One thing to note around a transistor is that it's not necessarily a all or nothing. That is, transistors can actually vary the amount of flow of electrons that flow through it depending on how much power we apply to it. So there's a whole range of powers that we can apply. In fact, a lot of amplifiers use the same concept. A little bit of power variance here can mean a lot of power variance here. So in the example of an amplifier, maybe we have anywhere from 0 volts to 5 volts that we put into one side, and we could get then from the other side anywhere from 0 volts to 48 volts. And therefore we can vary or step up the amperage, can amplify that signal on the other side. And that's how many of the amplifiers work. Now back to our solid state storage. So our charge trap can actually store variations of how much power we apply to it. Let's say we apply a little bit of power to it. Well, then it could store that state in this charge trap. Or let's say we apply a lot of power to it, and then we can apply, then it will store a lot of power or the potential of a lot of power in it. Now, even when we take away power from the gate, it's going to allow a certain amount of electricity to flow through here based off of what is in the charge trap. So if our variation of voltage is anywhere from 0 volts to 5 volts, what we could do is we could draw the line. Anything below this is going to be represented as a 0. Anything above this is going to be a 1 right here. And that's the initial Flash, how it was created. We just could represent either a 0 or a 1. But let's say we split this up differently. Let's say we split it in half, but then we split it in half again. Now what we could do is we could represent 2 different bits. This could be a 1, 1, this could be a 1, 0, this could be a 0, 1, and this could be a 0, 0. So now we've got a few different states, anything between 0 volts and 1.25 volts would be represented there. And then 2.5 volts, and then 3.75, and then 5 volts. So we've split this up to denote the different variations that we can have. In fact, this is one of the areas that we continue to make improvements on. We have the single level cell, or SLC. We got a multi-level cell, or double level cell. We've got the triple level cell. We got a quad level cell, we've got a penta level cell, and we'll continue to develop it. Although we do run into some issues. And as what we can see is we're able to represent more and more bits, the more ways that we can divide this up and continue to divide this up. So one of the limitations that we're running into is being able to detect the variances between these voltages. And here's what I mean by that. Let's take this right here, and I'm gonna split this in 2 and ask you, can you tell the difference in color between this and this right here? If I were to show you something on this side versus on this side, can you see the difference? Chances are you're gonna say yes. But now let's split it again. And can you see the difference between this color and this color? Probably still okay. But it's a little bit harder, isn't it? I'm going to split it again. And can you see the difference between here and here? And it's probably becoming even harder. Or I can split it again. And now can you tell the difference between, let's say, this one right here and this one right here? So our equipment, and we're talking about really small measurements that we're trying to measure here in really small components that we have. And so it becomes increasingly difficult to break this down. And so we are going to be reaching some limits if we haven't started to plateau already. So that's just one of the limitations with being able to extract more data out of each memory cell. During the time of this recording, a lot of our electronics are using this triple level cell.